Okay, good evening. Good evening, everyone. Sunita, Jelly, good evening. And Prabhagar, Varade, good evening. Hamid Hussain, good evening. Gayatri Subramani, good evening. And AKM, Alam Khan, good evening. Me, Tausu, Alif, good evening. Arun Kumar, sir, good evening. So, good evening, everyone. So, sorry for the 4 minutes delay. Okay, so now we can continue. So, once again, good evening to all, and welcome to this session. Welcome to the Pantech learning. So in this particular series, we will discuss about we was discuss about the what is generative, what is deep learning. So already 4 days you have to complete it, right? We have completed. So in that particular 4 days, previous 4 days, we will discuss lots of we was discuss about the lots of things. That is what is generative AI, or the example and applications. What is deep learning, how it is work, and the two kind of projects also we can we was discussed in that last previous sessions in deep learning concept. So now today we have to go with that another model of generative AI concept. Okay, so last session, yesterday session, we was discuss about the generative AI is having two kind of models. One is a GAN, another one is a VAE. So last class we was discuss about GAN model, and also one of the example also we can discuss. So now today's session we have to go and I learn with the particular VAE concept. So what is VAE, how it is work, and based on the VAE model, we will discuss one kind of project, like one example also. Okay. So before that, yesterday end of session, I was told, right. In next session, I have to show the exact output of the particular GAN model. So now we can see how it is happened. Then we have to re-entering into the VAE concept. Okay. Okay. So just a minute. Yeah. So now, okay. So this is the last session we have to discuss, right? So our tensor board, the output is not like well, right? So GAN model is the GAN model's major work. It is help to identify which one is real one and which kind of data is a fake one. That is the major concept in the GAN model. And so so we have to create one MNIST digit. What is the digit prediction, right? MNIST digit classification. So in that, based on the particular digits, like image, how many numbers of is a fake one, how many numbers is a real one. So here the MNIST fake images and the real image both are separately classified here, but the real image is not properly showing. Okay, so in this particular problem, we have to resolve it. So how to we can resolve this kind of issue? So you can see in this place we have to mention in only 10 epochs. Okay, only 10 kind of epochs we have to using for our training purpose. Then only this kind of things is happen. So in fake image also is having one or some similar numbers only it is showing well. So like this is a 3, I think it's 3, and it is a 7 or 9, and again the 3 is completed repeatedly comes and is 0. So not more than it is not a good one, right? We cannot easily understand. So what kind of number is present in this place. Okay, so we have to properly identify that. Okay, so now I have to go with that another one, so it is no needed. I'm going to open the another notebook of in Colab, Google Colab. So already I have the log file. So log file means in this particular place, okay, it is not connected. Okay, so once I say reconnected this one, okay, so not an issue. Okay, I think it's a yesterday file, still we cannot open, so then only the log files are not there. So I have a folder in this one. So in my folder, here the log files is here. Okay, so this is the concept. So last session we will discuss about this. Is the concept of GAN models, IPMB, code notebook, source code, and presentation, and what is that? The log file. That means inside the log file we have a training and testing, fake or real. Both are separately there. So it is a fake one folder. It is a real one. Another one is a real one folder. So in this folder, we have to upload in another file for our increasing the most number of epochs for our better output. Okay, so now I have to showing you. So once the collab will be open, I can go with that new notebook. So I have to create the new notebook one. And once upload the file, upload the log file, how to extract, that's everything I can show here. Okay, so once I connect with this with the GPU format, Okay, P4 GPU is important for, so it is easily identify the data and easily handling the data. Okay, I think most number of time I have to connect with this GPU, then only it is not connected here. Okay, so now, okay, so just connected. So wait a second. So once I have to upload the file, I have to upload the file as a zip file format. So already you can see here in this log file is having a zip file format. So I can directly extract the file in Colab. So I have to give us some kind of command lines, that is from zip file. Sorry, zip file and import zip file. Okay. So it is a command line. Then we have to extract with this with. Okay, once I have to see the command line, I have to forward this. Okay, with the zip file. Okay, sorry, with zip file of, I have to mention the command like file. Sorry, before that I have to upload the particular file, zip file. I have to upload in this particular place. Okay, so where the particular folder, so I have to select the log file, like log zip file. I have to upload it here. So in between that, okay, I have to upload the particular URL in this place. Apart from that, zip. So here zip dot extract all. Inside the one, I have to mention that is content logs. I think it is enough one. Yeah. Content log. This is the way I have to represent the particular file name. I mean extracted one. So store it into this kind of format. I think it is a error one with zip file. Okay. Zip file is not defined. Okay, so it is having some kind of issue. So once I can run this, so what kind of error we can resolve that? Okay, zip file is not there. Copy the path and paste it here also. Okay, just a minute, guys. Okay, it is not clicking. Okay, yeah. Hmm, I think is a capital one. Fine. Okay. The spelling is capital one. Z and F both are capital one, and also we have to read this kind of zip file. So we have to need a particular format. I have to read this file. So the R is represented with the read concept in Python file handling method. So if you know about the Python, you can easily understand this concept. And next everything is good. So now it is done. Once the zip file will extracted automatically stored in this place. You can see here the logs. It is a unzipped file. So inside the log file, the fake and the real both are separate folders is there. So we can easily use it for our better output. So now I have to mentioning that the particular tensor board extension. So it is extension to read our extensor board. So show it here. So load extraction of tensor board, and tensor board it is used to log file. So our file name is a logs. So I have to mention the log directory is in logs. So I am mentioning the particular data location as well as tensor board extension. So once I run this, so you can see the output of this. Okay, it takes sometimes. I kindly wait. Okay. Yeah, once it is done, yeah, the tensor board is shown here. So now we can see, so comparatively here, this is clear vision. Okay, now you can see the easily you can view the saw the particular numbers, right? So why it has happened means we have to increase the number of epochs. So before that, here we have to using only 10 number of epochs only. So here we have to use the 200 number of epochs. How it has happened means already we have to extract the log file. So in this log file is having separate folders is there. So we have to separately mention in this particular another folder another file. We have to easily increasing the number of epochs. Okay, so here the fake image is having the clear vision. So once I decreasing the particular steps, so it is showing like in step 33 is happening into it is not show properly showing. Okay, so I think it is not clear. It is 7, I think it is a 4, it's a 3. So some kind of numbers only it is viewed, some other thing is not showing properly. So once I increasing the epochs count, the visual is also variant. So you can see it here, every time I have to increasing the number of epochs, so the visual is also increasing. Okay, wait a second. Let's say close this. Yeah. So still it is mentioned in the 120th epoch. So again, if I increasing the size like epoch counts of 121, 129, 152, and 175, still it is a final one 200. So this time the fake images, objects are represented here. So directly we can go with the real image. You can see it here. It's also same like that. Once I decreasing the image count means it is not mentioning the noise one, but every images will be showing properly. Here once we can decreasing the image means it is a fake one because of it is not properly trained, and also we cannot see the proper shape in that particular object or particular number. So here it's a real image. So every time we can decrease or increasing the epochs, the numbers will be randomly changed. It is not much difference between the particular numbers variations. So you can see the step by step have to increase means randomly the number will be changed. Because of if this kind of numbers is a real one, then only it repeatedly comes like that in every epochs. So in each and every row and columns having range of 0 to still 9. Because our digit also same like MNIST is in 0 to 9th index only we have to represent. So every time I have to increase, randomly the numbers will be changed in the line and the row based on the step increasing wise, like the number of epochs training. Okay, so this is the way the GAN model will be work. It is working like that particular digits identification. So here the brightness will be, we can adjust easily. So once I decreasing the brightness is not showing, like number is not showing. You can see. So it's a minute view visual only showing here. So increase that, it is showing properly like this format. So it is a histogram plot. So overlay or offset. So whatever it is we have to change, the everything will be applied here. And so you have to mention it like ascending or descending. So if it is the characters are there means we can easily convert that it is ascending and descending format. Okay. So this is the way everything will happen. So it is the size of the particular card size increasing or decreasing like that way. So then we have to converting into the images. Okay, so image is not showing, I think. Yeah. Okay, so this is the way the GAN model will be working. So yesterday we have to discuss about the particular how the GAN will be working. Here you can see the output, how it is make a prediction about the particular numbers in a GAN model. Okay. So now next we have to entering into the VAE model. Okay, so yesterday I have to set VAE is one of the variation autoencoders. That is the major purposes. It is encoding the details from the particular image and it is reconstructed the same image look like that. That is simply we said it is copying the one original to another one. Copy the image from the original one. That is the major concept. That is called as a reconstructed one. The VAE model will be working like that. And if I have to set the example for this one means you know about the Ghibli art in recently trending, right? The Ghibli art. So in the particular Ghibli art is working into the based on our image, it is reconstructing into the animation format. That's it. The images are same, but it is reconstructed into the another format, like animated or cartoon way or pencil sketch, like that way. So whatever it is, we have to expect that based on our need wise, the particular image will be converted. So that is the VAE model. Okay. So the GAN model will be, it is identify it is a real one or fake one. The VAE model is working like a, it is reconstructing the particular one. Okay, now if an example, I have to one kind of code, okay, one code or any kind of problem is I have in mathematics, whatever it is. So I have to resolve the particular problem. I have to upload my particular file. So the zip file or else PDF file, anything. I have to upload the file into ChatGPT or any kind of model. I need to ask, so kindly resolve it. I'm facing this kind of problem. I have to resolve it. So I make a prompt like this. Automatically, the particular model will help to recover this error in that same file. As well as it is giving the same file, the same code and the same problems and the same steps are there. It is adding, it is changing the one particular line. Where it is the particular problem is there, the particular line only it is changed. Otherwise, every line will be represented in the same format. It's like it is also one of the example of VAE model. Okay. So now it's introduction of VAE. It is a variation autoencoder. It is a type of neural network and architecture that uses the deep learning to generate the new content, detect anomalies, and remove noise. And VAEs are part of the families of variational Bayesian methods, and probabilistic graphical models. So when using the generative models, if you could simply want to generate a random output and that look like similar to the training data, and you can certainly do that with the VAE. You can notify in this point, like you can see this point. So it generate the new one, but getting the features from the training data. Like that is the reconstructed image. The copy is also same like that, right? So getting the details from the particular one, the original one, it is take it to another image, like another sentence or another file, like that. So, but the more often you had like to alter or explore variations on data you already have, and not just in a random way either, but in a desired specific direction. That is the VAE to work better than any other method currently available. So the VAE's major work, it is working on it for the reconstructing the image based on our wish. So what kind of way we have to build the particular one. Okay. And okay, so it's the third point. Next one is an autoencoder. First, we have to differentiate what is autoencoder and what is variation autoencoder. We have to identify the difference, right? So you can see and know about that the encoding. So encoding. Okay. Yeah. Okay. Sorry. So generally, we know about that encoding is to gather the insights from the particular data. So if it is any kind of movies or any kind of story is there means, so we can encoding the details. So based on the posters, so recently the trending is there, right? Any movie posters is there, some kind of reviewers make a information from this day, like decode the particular information from this particular poster or any first look, like that way. So what is the encoding? So decoding means to find out the information from this particular one. So what is encoding? The encoder network is actually a pair of two connected networks on encoder and a decoder. So decoder, we know about that. So we can decode the particular, find out the information from this particular one. So but the encoder is it is represented the same values. An encoder network takes in an input and converts it into a smaller dense representation, which the decoder network can use to convert it back to the original input. So encoding is to get some kind of information from this particular original one. It is converting into the decoding format. I mean, it is helped to make that information from the particular image or particular data. That is encoding's major work. Okay. Yeah. So here the representation of encodings. So for the input image is there. So based on the original, it's a original image. Okay, based on the original input image, here is a encoder, is a decoder. In between the process, the some kind of layers, the deep learning layers will be applied in this place to find out the information from the features, like each and every features wise, it is extracted. So first the input will be passed into the encoding format. The encoding will be split the information based on the decoding format, and again the decoder will be find out the features based on the particular hidden layers. Finally, the reconstructed image will be built that. The decoder to help to assembling the every features based on the input image wise. So that's what sorry, this is the example of this one. So initial data is a space one and X is the initial data. The EX is an encoder encoded the data in latent space based on the particular values. The decoder is encoded in converting into the decoder data back into the initial space. I mean that means first one kind of structured image is there. The encoding will be splitted into the some kind of features wise. So based on the some kind of particles wise, it is splitted. Then latent space to extracting the information from that particular splitting neurons or splitting parts. The decoder will be find out the information. Finally, it is assembling the part. I mean assembling the every data when it is going to the reconstructed image. Sometimes it's happened. So some kind of data or loss values are increased. So it is affected the particular output in a final reconstructed image. Some kind of part is missing. So sometimes it happens because we can reconstruct. We cannot directly pass it the image. Once we can take the information from the particular original image, then we have to reconstruct in the same one. Okay. So it is having lossless encoding and lossy encoding. The lossless means no information is lost when reducing the number of dimensions. Lossy means some kind of information will be lost when the reducing the number of dimensions. It cannot be recovered later. These are two kind of formulas is there, so we cannot directly apply in this. It is based on the formula wise it is executed. So it's a format. So it is our input image. The input image is passing into the encoder and encoding the values. Finally, the decoder will be assembling that. Reconstructive image will be that. Just an example I have to showing the like this format. In project wise we have to see one kind of example how it is reconstructing the one original image into the reconstructed one. So we will see that how it has happened. And okay, it's a latent space introduction. The primary challenge with the autoencoders, it is particularly for generative purposes, is that the latent space they map their inputs to may lack continuity or hinder the straightforward interpolation between the encoded vectors. And the latent space is learned by the basic autoencoder may not have a meaningful or continuous structure, making it challenging to interrupt to use for generative tasks. The latent space major work to extracting the meaningful, that means that's just now I said, right, the continuous structure based on the important features only it is extracted from the particular encoder, like encoding. Then it is the values are processed into the decoder. The latent space major work to extracting the features. Okay. Next one, for example, the training autoencoder on the MNIST dataset and visualizing the encoding from the 2D latent space reveals the information to distinct cluster. If the space has been discontinuous, the gap between the clusters, and you sample or generator one, it is a variant from the decoder will simply generate an unrealistic output because the decoder has no idea how to deal with that region on the latent space. So I said some kind of loss values is happen means the decoder is not properly reconstructed the particular image because you don't know about the particular data. So what is exactly, how can we assembly in this one based on the loss values count is increase or decrease. Based on that, the decoder will be reconstructing the constructed the particular image. Okay. So it is an example of the splitting the clusters. So here the 9 still 0 to 9. So it is a MNIST is an example. Okay, based on the index value wise. So everything is equally splitted means it is properly reconstructing the particular image. In case one or two only it is properly showing, so another one is not properly that not equally splitted means it is not proper. I mean, what is it? It is not getting the one proper structured format. For example, I have represented the one teacup or teapot image, okay, or any kettle image or whatever it is. If I give example, I have to give it that. I have to reconstruct the image in the output. So in case most of the loss values is there means I cannot build that. Like I cannot reconstruct the particular image. Maybe the what is that, the kettle only is there, the handle is not represent. On handle only is there, the kettle is not represent. Based on like that with the images maybe it's reconstructed based on our loss values. Okay. And next one, so what is VAE, like what variation autoencoders? So it is have one fundamentally unique property that separates them from the like various spelling mistake variation autoencoders, and it is this property that makes them so useful for generative modeling. The latent space are by design continuous, allowing the easy random sampling and interpolation. So then only the VAE models will be working the major role played in this particular case. It's help to allowing the random values. I mean, it is help to split the values into the equal format. So to achieve this, the encoder deviates from the conventional practice of producing a single encoding vector of size n. So the number of sizes, it will not represent one particular value. Instead of it outputs two vectors of the size, it is the one representing is the mu, another one is a sigma. So the mu symbol is represent to the okay, standard deviation. Yeah, one is a represent value, another one is a standard deviation. So here the input will be that the input is mentioned like a dense layer having 501. So our original the image is splitting into the neuron wise, that is 500 count of neurons is there in that particular image. Okay. Then the image will be filtering into the 120. The 120 is represent to the feature one. That means 120 pixels only having the particular features, the parts image value is there. In this particular 120 is splitting into the mu and the standard deviation. Both are randomly, equally split that. Finally, the sample value will be there. So based on the splitting and the feature analyzing wise, the sample value comes like a 30. Once the 30 will be increased that, the decoding, like decoder model will assembling the values based on the numbers and the loss values, etc. Again, it comes to the 120. Finally, it comes to the 500 value because we know about that. So the input value is a 500. So our output also 500. The both are 500, but the properly it's reconstructed or not. That is our important one, our final output. Values is not a matter. Okay, it is we need to getting the proper constructed image one. We need. Okay. And the next one, it is a process of the particular one. So input image is splitting into the neuron base. Already we know about that. How would the deep learning will be splitting the data and everything like. The x1, x2 is the neurons. It is passing into the randomly crossover into the every layers. The encoding process. So it is a variational and like mean value and the standard variation based on the latent space. So sample distribution will be there. In this particular sample distribution, to constructing the based on values, like decoder will be extracting the features. Okay, so based on this particular value, it is represent to the particular image, like in this pot or kettle, whatever it is. Finally, it is again is reconstructed the one particular image. Finally, we have to identify it is our original one or not. Okay, it is properly reconstructed or not. So it is a real world example of VAE model. So our input images. So it is our input image is a cat image. Cat is our input image. Then we have to find out into the encoding network. That is a convolutional encoding network. It's help to splitting the values. It is move on to the standard deviation and mean values. These both are equally assigning the selecting the features. Then it is again passed into the decoder format. That is a sample latent vector, some kind of sample value. It is provided to the decoder form. Model. The decoder model only it is identify. Okay, it is this kind of one, and we have to extracted this. We have to reconstruct this image for our output. In final output, it is not properly, it is finally properly constructed or not, we have to decide. So already you know about that, it is not properly reconstructed means we have two kind of things. One is the backward propagation, otherwise we have to go with that enhance the training number of epochs, enhancing the number of epoch training epochs, sorry. So it is already we know about that. So everything is equally splitted, but it is not like that. So yeah, I think it is 0 and which kind of color is more than that? 0 and 1, it is most number of values is splitted. Others is very less. So which one is, I think 8 and 7 is less. Same like that 9, 8, 7, 8, 9. These three kind of values is very less count of clusters is there. So why it is happen like that means it is not properly encoding the values. So however, the sampling process requires some extra attention. So when the training model, we need to be able to calculate the relationship of each parameter in the network with respect to the final output loss using a technique known as a back propagation. So just now I said we have two kind of options. One is increasing the training epoch count. Otherwise, we have to do the back propagation based on the parameter network wise. However, we simply cannot do this for a random sampling process means. Fortunately, we can leverage a clever idea known as the reparameterization trick. That is the reparameterization means same like us, it is a backward propagation. That's it. It is not much different between the both words, reparameterization and backward propagation. It is a VAE model's major work. It's a reconstructed image, right? So same like that here also. So reparameterization is a key concept in VAE model that facilitates the training process and enables the back propagation of gradient through the stochastic latent space. In VAEs, the encoder typically output two kind of vectors. Already we know it's a mu and the mean value and it's a standard deviation value in the multivariate normal distribution. And the reparameterization is the technique used to sample from this distribution in a way that allows for the computational of gradients during the back propagation. So it is adding some values in the distribution. If here we can see the value, right? So it is this is called as a distribution. So every value is equally splitting like that. That is called a distribution. In every distribution, the parameterization is used to do technique. The sample values are equally computed. That means it is equally assigning the values into splitting format. When it is splitting format is here, the values are equally splitted. I mean equal range based on the ratio wise 3:3, 4:4 like that way. Instead of the direct sampling from the distribution represented by the mean or standard deviation value, which would make the propagation challenging due to the non-differentiable nature of the sampling operation, and the reparameterization trick involved the sampling from a standard normal distribution with the mean and the standard deviation. The mean is represented with 0 and the standard deviation represented with 1. The number way only system can understand, right? So we can mention like that, and then transforming these samples to match the desired distribution defined by the mu as well as mean as well as standard deviation. Okay. So decoder and the decoder model like three parameterization process. So deterministic node and a random node. So what is the difference between the both means? It is before reparameterization, it is after reparameterization. Before that, our value will be randomly assigned. Random noise value will be assigning in the particular decoding model. Then only the reconstructed image is not well. Once we have to do with the reparameterization means the back propagation is allowed to the determined value. That means the fixed value only it is allowed. Otherwise, it is not allowed the particular values. Encoding to decoding. You can see, so here the two values only mu and standard deviation is there. Once it is going to the normal propagation in forward propagation, we have to do with the reparameterization. The reparameterization value will be ignore the particular normal value and is assigning in the same like replacing into the same place. So this reparameterization tricks allow the gradient of the sampled latent variable with respect to the parameters mean and standard deviation to easily computed and enabling the efficient back propagation during the training process. It plays a crucial role in the training, and the VAE it is making them like amenable to gradient based optimization algorithm. So optimization means it is not getting the lag of the particular training during the training process. So same like as we need a loss values, right? So in GAN model we need a discriminated loss and generated loss. Same like it's here. We have two kind of loss: reconstructed loss or KL divergence loss. So based on the model wise, we have to fix this kind of two functions. Okay, so it's the same like that. we have to using the digit MNIST digit generation. It is a GAN model process. Yeah, it's a GAN model process. Here in this VAE also we have to using the MNIST cloth cloth identification. MNIST cloth fashion MNI, that is called as a fashion MNIST. Fashion means it represents the cloths. So what kind of cloths? If I have to represent the one image, it is a shirt image means the original shirt image, based on that the reconstructed one will be created based on the VAE model. Okay. So I have to show how it has happened in this one. Okay, once I reconnect this and okay. Okay, once I before that entering into the code concept, I have run the every steps because it is taking too much time of epoch training. So it is nearly 25 count of epochs. I think. So just a minute. Yeah, no, it is 10. Okay, it is enough for us. So I will start with that libraries. First, our major thing is Torch. Torch is an important library to deep learning concept. So already we know about that particular installation process. So to install Torch, right? So the syntax is help to create the particular libraries, cache files, and everything. And okay, so once it is done means already you have the library, you can get it. It is a requirement already satisfied. Otherwise, you can collect the files and libraries, everything like this format. So once it is installing like this format. Okay, so it is take sometimes. So kindly wait. Once it is done, you can go with that. Okay, yeah, it is almost done. Okay, once it is done, we have to discuss about that. So here another libraries we have to import. So task we have to install that. The same process will install into the every libraries. So next numpy is help to handling the numerical values, and data loader same like as GAN model. So GAN model we have to using the MNIST digit calculation. Here we have to using the MNIST fashion MNIST. That's it. So both are same. Here we can using the images, cloth images. We have to reconstructing process. Then the torch.neural network, we have to assign a neural network, and the transforms help to make the data from the image to pixel value. And the plot, we have to creating the plottings to the particular image. And then torch vision and supporting library, and functional is mentioning like accepting the functions. Then auto grade is help to optimizer. So model optimizer we need, right? That is Adam optimizer help to optimizing the model. This optimization is more important to it is avoiding the lagging or bugging in our code during the training process. Okay, so now I import this kind of important libraries. Then I have to import that. Until I run this cell, so everything have to clear. Okay, so now I have to go. Oh, sorry. Okay, so now I have to run this. So here same like that, our device is a CUDA or CPU, whatever it is, based on our hardware unit wise it is represent. So it is CUDA means it's represent to the CUDA, or else CPU means it's CPU. I think my device is CPU format. Yeah, right, because most number of times I have to open this kind of same file, then it has happened. So it is already run one. So it is I have already used this file. So then it is not getting some different, I mean, variations about the CPU to GPU. Once you can newly use this file means definitely you can use in this GPU format, T4 GPU. Okay. Next one, we have to compose in the transformers into the equal value, that is normalization of 0.5. So already we know about this everything. Data set will be creation into the data set fashion MNIST. Last one MNIST digit. Here it is a fashion MNIST. It is represented to the clothings. The data is the URL of the particular data, and the download is a true, train is a true, and the transform is a value. So before that, here it is not values is that. Once I run this, the values will be created. Once I run this, once the percentage will be completed, so we have to see in our file manager the data set. Now it's done. So I have to check in the file manager. So refresh the page. Okay. Okay, so I think it's not needed. So maybe it is hide the file. Okay. So next we have to identify the index value. So based on the which kind of image is represented with which kind of index. So already we know in the last class the based on the each and every number is represented with the index value. Here also same like that, the data set dot class to index of the particular value. Here the t-shirt or tops both are represented with the 0, 1, 0th index. The trouser is represented with the first index, the pullover is the second index, dress is the third index, and the coat is the fourth index, sandal like slippers is the fifth index, shirt is the sixth index, sneaker is the seventh index, bag is the eighth index, and ankle boot is the ninth index. So each and everything is represented the every index values based on the index values. So then have to list out the classes into the keys format. Then have to load the values. So data loader to data set. The batch size is 128. Here is the image, right? Last class, like last session, we have to discuss the 36 batch size, right? Here is a 128 because the every clothing is represented the highest pixel values. And only it has happened. We have to enhance in the what is that batch size also. So fig of axis based on the subplots, and axis represent to the each and like it is randomly executed the image one by one. That means one by one means some kind of number of values. So here the 1 cross 6 means seeing in one row the 6 kind of images will be represented here. So you can you can see this single row 6 kind of images, like 6 kind of product will be represented. So pullover means it's a full on t-shirt, bag, and the sandal is the normal slipper. Again sandal also is again sandal. So randomly there. It's not a fixed one. So again run this, the product will be changed. You can see the dress, the shirt, sandal, again it's a t-shirt or top or coat or bag. So every time I run this one, so randomly the values will be represented here. If I have to changing the count of this one, I represent is 0, I mean 7 means 7 kind of products will be there. So it is 7. We represent with the 3 means 3 products only represent here. So like this. So 2 comma 3 means 2 rows and 3 columns. So based on the count wise, the 2 rows, 1 and 2 rows and 3 columns. 1, 2, 3. Right? That is our wish. Based on wise we can represent this one. Next we have to go with that encoding and parameterization and decoding format. So we have to creating the VAE model of the class one, and init the same like that parent init function, and the super is support like child function. Self dot input layer is mentioned like a linear layer. So linear layer starting with a 784 neurons starting count. So our reconstructed count also same comes like a same format. Then only we have to easily identify it is a reconstructed or not. The mu value and sigma value, and upscale the sample, and again output layer is having 784. So input layer having 784, it is starting neuron value. Once it is comes to the output layer, it is again it's represent to the 784 one. The encoding will be based on the values, so it is representation, and sigma will be reparameterization of this one. Based on the tensor value, it is represent. So touch.cuda means it is a normal, I mean batch new size will be variant. The normal CPU format bit is here also the batch new size will be variant. And the return of the sample one. So def the decode value will be dot sigmoid of the output layer. Once it is not having any issues means it will do with the forward propagation. In case we need to backward propagation means we have to create the backward of the particular one, another format. Another process. So first one already we need create the model. So class model, where is that? The VAE model. So model is equal to VAE to device which represent here to create the model. Then we have to check the model. So VAE having input layer. So the every neurons will passing into the input layer, right? So input feature is a 784. Again, when it is comes to the output feature, that also same equal value, that is 784 is output feature. Based on the models, the model is entering into 784. Output also same kind of neuron count of neuron is needed. Then only we have to fix, okay, some kind of output is there. So we have to check it is a reconstructed or not. So next one, it is a loss function. The def loss function will be there. It's a reconstructed image will be need and a real one, and based on the new and the sigma value. And image loss means the neural network dot mean squared error loss. Sum of reconstructed and real. So based on the KL divergence loss value is a 0.5 based on our hidden layers loss value. Finally, it is returned to the image loss and the KL divergence loss. Okay, I'm not run this before cells. Yeah, okay. So next, the optimizer will be Adam optimizer. Already told multiple times. The Adam optimizer is a fit for our deep learning concept. It is a common default one. Okay, I have to run all cells. So we have to wait to run this particular one. Yeah, definitely. In last session, GAN model as well as VAE, both kind of presentations and source code, everything I was shared in a group in this particular after this session. After this session, you can try with yourself. And yeah, Amit Kumar, sir, thank you, sir. Thank you for your support. So attendance link every time same like us. In the end of the session, we have to share. So kindly wait. Okay, I think I have to check my internet because it's taking too much time to execute. Okay, so because of my library will be installed, so immediately this happen. Okay, it takes too much time. No, today is not the last one. Tomorrow is the last session. So tomorrow we have to discuss in one kind of model we have to take and initializing the third project. So already it was done only two kind of projects, right? So tomorrow we have to see the last project, that is crop monitoring, I think, right? So we have to see that, and finally we have to wind up the FDP in next tomorrow session. Yeah, right. Because of already in the library, library installation is taking too much process because it starts is having some more number of catchy files than what it has happened. So otherwise, everything will be done in a minutes. So now it's done, right? You can the optimizer also done. So optimizer is a Adam optimizer. The model will be parameters based on the E minus T. So it is reducing the multi-dimension to 2 dimension. Okay. Here the epochs will be started here. So I have to represent the 10 kind of epochs. So based on the epochs count wise, our I mean reconstructed image will be good. But what is the major work means it is take too much time. Then only it is happening here. Yeah, of course. Our case study tech, of course, task will be take too much time because it is handling the image data, right? And only it is having much kind of catchy files and the package files, everything. So based on the looping concept, right, each and every epoch will be there. Last values and the k dimensional values will be executed here. So here the image view and variable value and optimizer also represent, I mean, the mentioned it here. Finally, we have to see the steps of optimizer, model optimizer. Yeah, it's almost done with the 5 epoch only. So we have to wait. It is around 7. So when it is 9 means the epoch will be done. Yeah, Nitesh, that also one of the problems here also. So GPU is most support to the much number of data and also training and everything. So colab is an online editor, right? So I have using multiple times. Only it is happened. Sometimes it has happened. So in notification message, oh, I don't know how many people will notify that without. I mean, you can connect only without GPU like that way. If I newly created this model or trained this model means I can definitely I can get it the error or some kind of lags because of the image data. Here it is not like that, so then only it is happened. Yeah, so now the last value will be done. So next the model evaluation. So as well as we have to evaluate the model. The model ought to evaluate of the image based on the data loader. Here, why we have to using the data loader means based on our data set, we have to comparing the image and reconstructed that one also. So yeah, evaluated of this particular image and the revaluation of the image and the evaluate the mu value and the sigma value to encoding the values is parameter based on the tensor value. So mu value and sigma will be using for reparameterization and model to decode the values based on the CPU to reshaping the values into 28, that is 28 28 pixel value, and supply also 1 comma 2, that means in single row 2 comma like two kind of image, original image one and reconstructed image one, both are represented here. So it is represent to the image, I mean images text, so title and execute the image and reconstruct the image and everything. So here original image I have to represent to the blue R, so I have to represent to the blue R. The reconstructed is represented to the gray R. So you can see this one. So original image is one of the t-shirt. The reconstructed one is a based on the shape will be there, but it is not accurately reconstructed the image. Okay. Yeah, I think the value effect is not there. So blues are. So this one also already I told this. So if you need to changing the effect of the particular background or the image means you have to give any mistakes in the particular place. You can get it the proper like multiple effect names, effects name. I mean the particular shades name. Here the original image is represented with the blue or the reconstructed is in like this gray or I mean black and white. Here you can see the original image is a blue. I think it is a negative frame like that way. Okay. So the image is pant. I mean trouser image. The reconstructed also same like that. So we need to giving the proper one. Okay, I have to mention to cool warm. I can try with this cool warm R. Yeah, now we're in this. Yeah, you can see the original image is a t-shirt one Reconsideration also the same like a t-shirt, but it is not, it is getting the outline of the particular shape, but it is not properly using the original image one. Okay, so this is the way you have to represent the image. Every time you have to run this, you can easily see the thing. Like it's a ankle boot, right? I think boot or ankle boot, anything. So it is a sandal, so you can see the reconstructed it is not properly reconstructed the particular sandal slipper because of some kind of loss values is there, then only it is happened. So we can see the another one. No, every sandal image is not properly trained by that. So a trouser is properly there, and then image, I mean full top is properly there, and boots also same like that properly is here. Bag also look like good. Only I mean the slipper, sandal slipper only it is not properly trained. You can see is only the heel place only, heels place only there, others is not represent, right? This is the way the VAE model will be working, and the size also we can change. So yeah, you can see it here, 1 cross 2, 1 up. That means in one single row, 2 images, right? We can try this. 2 row and a single image. We can try this one. It is a up and down format. Okay, so this is the thing. This is the way the VAE model will be working. So tomorrow is the last session of our FDP series. That particular session we have to discuss about the agriculture field, like on pending project is there, right? That is a crop monitoring. We have to identify the particular project, and we can see that. Okay, so if I have any doubt, you can ask now. So most of, yeah, amazing grace is the correct construction of image depends on the training model, right? Yeah, of course, of course. So here we can using the some kind of MNIST data, right? So we can say it like that, it is a training one or else original one. So whatever it is, we can use to reconstructing the image. It is taking the information, I mean, features from the particular original one, right? No, no. It is just an example, okay, how the VAE model will be working. So it's just an example. I have to show this particular concept. So I have to try to train the particular agriculture field. That means any kind of crops we have to represent that. The same crop we have to reconstructing in this model. I will try to find out the particular same concept in the agriculture field. That's why you have to understood this kind of concept. Okay, so then only I using this VAE model just an example. So you also try follow the same process. You have to changing the data set. Okay, the process will be same. So you have to change the data set and some kind of features only you have to change. Like the index is differ, as well as the normalization also is differ based on the image and data size. Otherwise, the process will be same. So every process will be same. So I try to in myself I try to create the particular same crop monitoring in this particular VAE or GAN model. You also try with yourself because you every people you said give some positive response for us, and thank you for that. I think you have to understand, right? So you try with yourself. In case any query or any mistake or any errors, you can post that your query in the WhatsApp group. We will reply. I will reply to you. So you have to sort out the errors. Once we have to work with that any kind of things, then only we can getting some kind of idea. Okay, apart from that, we cannot having any kind of things, right? Here anything is there, you can ask. So Anil Kumar sir, so if just an example I have to show, it is not exact project of our agriculture field. So tomorrow we have to see the project in this same process. Not only GAN model. So GAN and there is a major model. Okay, I have tried to create GAN or VAE. Any one kind of model I have to take implement in our crop. I mean agriculture field process like topic in our topic. I'm not mentioning only GAN model. Probably we know the GAN is it is a fake on tail one, right? Same like us. It is a good crop or it is a not well, I mean affected or non-affected, like that way also we can try to create in a GAN model, or else we have to reconstructing the particular crop means we have to using the VAE model. So the both models having a different and unique processes there. The GAN model is only detected, so classify the crop, it is a good one or bad one, like that way. The VAE is a reconstructed one. Okay, so I tried both kind of process, I have to implement that. So which one is on getting output, we have to share, I have to share you, I have to teach you also and share the knowledge also. Yeah, so day 5 attendance also we have to share it here. So kindly fill it your attendance, so don't forget. Like the feedback link was shared into your group, WhatsApp group, so you can give your feedback in that particular link. MATLAB code. Right, sir, but it takes some time, sir. I have some kind of commitments. So I have to try. I have to try to create the MATLAB code. Manjula Babu, ma'am, we was sharing the code in your group. Okay, you can follow that. So you can take the same concept. Okay, same file. Just you have to, if you try with another any concept, you have to change the data set. So based on your target, which you have to change the data set. For example, I have to using the cars mean have to reconstruct my own car into the reconstructed image means I have to change in the data set. So same like it here also. The process will be common. So some kind of minor changes only you have to do. Yeah. And Anil Kumar sir, I have to try to create the MATLAB sir. I don't know about the MATLAB in-depth concept. The basic only I need, like I know. So I try to create the code in that MATLAB sir. Okay, anything is here. So don't forget to give it your attendance. So tomorrow is the last session. So tomorrow we have to discuss in your AV quiz, and still we will complete at the we was completed the 5 days, right? So in final session we have discussed one kind of project as well as we was what is that? Once recall the every concepts, right? I think I was sharing the three kind of project. I like two projects I was already shared in a group, right? Day 1, 2, 3 was shared. 4, 5 I share it today, and another 6 one is an after the last session I have to sharing the every balance code and everything. Okay, then anything is there? Otherwise, if you miss the data set, if you need to directly get the data set means you can go with the Kaggle. So already I said this process, right? How to collect the data set and everything. You can go with the Kaggle and search that. what is that? For example, MNIST or fashion MNIST. You can search like that. You can see the fashion MNIST. So here the fashion MNIST and then sign language MNIST and then Chinese MNIST. So based on the some kind of MNIST images and clothing and models, everything. So first one is in our just now I have to using the data, right? So this is the first one. It's our data model. So it is a pixel values only there. So image is also there. You can see. Okay, it is not one. Now here you can see the label and the description. So 0th index t-shirt top. So every images will be there. So based on the folder wise, 1000 count of images is there. So trouser is having 1000 images. So you can see the every tops and shirt. So varieties of tops and the shirt will be there for our training purpose. So t-shirt and tops is represent to that. Okay, where will I go with it? If you have to need the go with the toggle and choosing the second one. First one is having the pixel values, so you don't choose that one. You can choose the second one, the fashion MNIST PNG. That is the image data. So we have to using to our VAE model. Okay, so this is the concept we have to use. I have to try the agriculture MNIST. Anything is there? If it is there, means it's easy to our work to create the particular one. Okay, it is not there. So I have to change in the try to search in a different platform for searching the data set for agriculture in MNIST. Okay, okay, sorry. Yeah. Okay, thank you everyone. Thank you for your time and thank you for your attention and everything. I hope you understand. So today, after this session, I have to sharing the everything like code source file, everything. So you have to try with yourself. Any doubt you can ask anytime, like in next session or else what is that in your group. So whatever it is, you can ask. We will discuss about that. Yeah. Okay. Thank you so much. Saroj Kumar sir, thank you, and Praveen Kumar sir, thank you, and Kishore sir, Mark sir, thank you sir, Doctor Kishore Sharma. Rajalakshmi ma'am, thank you everyone. So we will meet in the next. Yeah, definitely sir. So just today after session I have to share the both. So yesterday and today both the source codes and every materials I have to share. So based on our need, ma'am, Smitha Boy. So based on our need, if I have to any crop varieties means I have to search with that crop varieties. Can you share the crop varieties in this particular one? So like that way, whatever we need, what kind of thing we have to focus, we have to take the particular data set. Or else any condition about the crop condition based on the it is fit for this kind of soil. So based on the target wise, you have to choosing the data set. Other than Kaggle means we have to using UCI machine learning repository. That's one of the Kaggle or the GitHub is better platform to collect the data. So UCI machine learning repository. So it is one of the platform to collect the data sets. So you can see just the same like that Kaggle. So you have yeah Padmarasan again. Yeah, thank you sir. Thank you so much. Okay, Manavalan sir. So thank you sir. Thank you for your reviews and feedback. Okay, thank you so much. Thank you all. We'll meet with the next session and see you. Any kind of queries, you can contact with us anytime in WhatsApp group. See you. Yeah, definitely. So, um, I'm sorry for that. So, not only Maria ma'am, so everyone kindly be aware. So once we have shared the attendance link, you can follow up our live and give the attendance in that during the live session. So once you can for I mean what is that? Once you can fail the attendance, we cannot do anything. So once it's limited time only, the attendance is there. So still I have to wait. So who are all not filled it your attendance? Kindly fill your day 5 attendance. Ah, okay. Thank you. Thank you so much. Thank you everyone. We'll meet with the next session and see you.